Students, can you see the PPT? Okay, students. You will get the link in the chat box. Okay, you can join the whiteboard here, this whiteboard. Whatever notes I am writing, that you can download as a PDF later. You can check the chat box. You would have got the link in that here, the message box. Here, just click and you can join there. Students, I'm starting the lecture 2. Okay, the lecture 2 is about network protocols, protocol specifications, network standards, TCP IP versus OSI layer and packet generation, crypto placements, protocol addressing, and protocols headers. So, what is a network protocol? Okay, so network layers use protocols, and protocols are designed to provide a set of functions that are defined by standard, and the standards are defined by international organizations. Okay, let us discuss with examples. Okay, then only you will understand. Can you see the Jamboard? Can you see the whiteboard here? Students, are you able to see the whiteboard? Am I connected? Can you hear me? Okay, can you see the whiteboard? I was asking you. Okay, now, yeah. First, let me go to the network layers. Okay, so if you take the network layers, OSI is an example for network layer, and another one is TCP IP. Okay, we will discuss that. So OSI layer can be categorized into application, presentation, session, transport, network, data link, and physical. Okay, so so here in the TCP they are merged into application, and these two are clubbed into transport. Okay, then network and data link and physical. So in some references, these two also are joined together, and in some references, the TCP/IP they are referred as a separate layer. So please understand what are network layers means. We will discuss about the layers throughout this lecture. So please try to understand what are the different layers. The layers, okay, are referred according to OSI and according to TCP/IP. So OSI standard says that application, presentation, session, transport, network, data link, and physical. And TCP/IP application, transport, network, data link, and physical. Is it clear, students? Then there are many protocols that are running in different layers. For example, let's say in application layer we have a protocol called HTTP. In network layer, let's say we have IP. In transport layer, let's say we have TCP. So like that, we have many protocols, and each protocol they do some specific functions. Okay, and these protocols are defined using a standard means set of rules. Okay, and these standards are given by some international organizations. So that is what given in the slide number 1. Now you can understand network layers. You know what is a network layers. Okay, so network layer can be OSI or TCP/IP. Okay, so these are the network layers. Okay, so network layers they have protocols. Okay, example you can see HTTP, TCP, IP. These are the names of the protocols. So please understand these layers they have protocols. So what is a protocol? Protocols are designed to do some function. Okay, for example, um, these protocols they have different functions. Okay, so for example the TCP protocol it does the function that is defined in the transport layer. So it transports the segments from one node to the another node. Okay, the IP protocol basically does the function of the network layer. Okay, so it basically transmits routes the packets, okay, across different networks and take the packets to the destination system. Okay, so HTTP protocol does the function which are required for the web applications, okay, web traffics. Okay, so please understand each protocol they do different functions. Okay, so protocols are designed to provide a set of functions. They do some functions, and these function has to be defined by a standard. Okay, what is a standard? You will see in the coming slide. Standard. Now I can tell you set of rules. Okay, so the standard is very important. Okay, the protocols has to be standardized. Why it has to be standardized? I give you a brief understanding, brief information to you for your understanding. See, we have many systems, many types of systems. For example, hardwares, softwares. Like you take a laptop, we have HP laptop, Dell laptop, Apple, and we have mobile devices like Samsung, Apple. Okay, we have many devices, and each device they use different operating systems like Windows, Linux, Macintosh, iOS, Android. Clear. So when a protocol has to be accepted by different hardware and software, okay, then they have to follow a common rule set of rules, and these rules are nothing but standard. So some organizations like IEEE, ITEF, Okay, there are many organizations, and see these organizations, what they do, they define the standard. So when they define the standard, the protocol developers, they have to design the protocol according to the standard, so that there can be interoperability. Any different devices, different softwares, they can talk to each other, they can communicate with each other. If there is no standard, then these different devices, heterogeneous devices, they cannot communicate with each other. Okay, so this is what these are the informations given in the slide 1, 2, 3. Am I clear? Do you understand? Can I continue, students? Hello, students. Okay, so if please, if you cannot hear me, if any voice break up, or if you don't understand, please stop. Otherwise, I just keep going. Now, next one is called open protocols versus, okay, closed protocols. Some of the protocols, okay, for example, for example, let's say you have a client and you have your server. You want to connect with the server in a secured manner. Okay, we can, if you want to connect with a secured manner for administration purpose, and you want to do some configurations here, you want to do some administrative works here, then you can go for SSH protocol. So here this SSH, there is called open SSH. Okay, this is the example for open protocol. Okay, so similarly, please understand there are many protocols. Unlike open protocols, they are called as proprietary protocols. Proprietary protocols means the protocols which belong to Cisco. The protocol belong to Cisco. Okay, the protocol belong to Cisco, then or Microsoft. Okay, so these are vendors. So these vendors, they develop products for them, and these protocols are proprietary protocols. These protocols belong to a specific vendor. We cannot access the code actually. Okay, we cannot access the code, we cannot comment on the code, whereas the open SSH protocol, we can see the logic, we can see the algorithm, we can see the code, we can give the feedback. Okay, so that would be considered and revised. So this is the difference between the open and the proprietary protocols. So open protocol, see, I have given some points, highlighted the points so that it is easy for you to understand. So open protocol are subject to many rounds of review. That's the important point. So when someone develop, okay, the open protocols, please understand how they are developed. So they are developed as a community. Okay, the programmers, the researchers, they in the internet, they work as a community. Okay, so they work as a community. These are users. So what they do, they interact with each other. So let's say they put the protocol Others they give the review any feedback, okay, suggestions for improvement. So open protocols subject to many rounds of review. That means the members in the community they give the review feedback. Okay, so this is called request for comment, actually RFC. So open protocols it can be reviewed by others in the community, and this would help the protocol to be improvised. But one of the problem of this protocol is open protocol is that it is easier to discover the security flaws. So please understand, everyone they know the structure of the protocol, they know the logic behind that. So the point is, it is easier to discover the security flaws because we can see, analyze the code, we can find the weakness, and the people can easily discover the security weakness in the protocol. So this is one of the important point that has to be considered. Closed protocol means it belongs to some vendor like Cisco, like Juniper, like Microsoft. These organizations they develop protocols, and these protocols are belong to a specific vendor. You understand? Impractical to use proprietary protocols since multiple vendors need to interoperate. For example, students, the point here is, if you take a open protocol, different vendors they can use, they can interoperate. But the proprietary protocols, some protocols, if they are not standardized, if they are not based on a specific standard, then that can only be used within the products developed by a specific vendor like Cisco routers. You understand? So for example, you have Huawei, then you have Juniper. These are some of the routing and switching vendors. So Cisco routers they connect the Cisco devices. Juniper protocols they use they work in the Juniper routers and switches. So these are the drawbacks of the proprietary protocols. Okay, with a proprietary protocol, it is more difficult to discover the security flaws. So the point is, whereas here, open protocol, it is easier to discover the security flaws. But in the case of closed or proprietary protocols, please understand, it is difficult to discover the security flaws. Why? Because the logic is not revealed outside. Understand, it belongs to the company, the algorithm. You get the point? So maybe this gives some amount of difficulty to the attackers. Whereas in the case of open protocol, it is easier to discover the security flaws in the protocol. So this is the difference, students. Open protocol is developed by community members. Even you can become a member of some community, and you can give the review comment. You can try to analyze the code. You can give the review comment, and if it is acceptable, the community would accept. But the only important the important drawback of this protocol is that it is easier to discover the security weakness. Okay, the another important point regarding the closed protocols, they belong to a specific vendor. They are not suitable when you want to connect heterogeneous devices. Yani devices from different vendors, if you want to connect, then the proprietary protocol doesn't suit, whereas the open protocol is very good in that situation. And also regarding the proprietary protocol, the logic, the algorithm, the structure of the protocol is not revealed out. So it is difficult to discover the security flaws. Students, are you there? Can you follow up to this? Students? Next one. What is a standard? I already told you the importance of standard. If there is no standard, students, any protocol which are designed, they, if they are not following the standard, understand, then they cannot be used in heterogeneous devices. They cannot be used in different devices with a different operating system. If that is called interoperability. One student would be having, you would be having Huawei phone, another student would be having Apple phone, another student would be having Android phone. So they are, you people are able to connect, we are able to connect to each other with different devices, different operating systems. How? Because these devices, they use softwares, and they have network layers, support network layers, and these network layers have protocols. These protocols, they are based on some standards. If they are not based on standard, then the interoperability yani we are able to communicate with different devices and different operating system. No, that is not possible. So standard is very important. The standard means set of rules for data communication. Okay. So what the standard will tell? Okay, for example, someone is going to develop a hardware, software. Okay, hardware or software. Okay, some network protocol. Okay, then they have to follow the standard. So what guidelines, what instructions, what talimat, what kind of instructions the standard they give? Okay, let us see. The first point is, you have many network layers, understand? So they will, these standards will specify, they, it will tell, inform, okay, what service access point from each layers have to produce. Okay, for example, let's come back here. So we have so many layers. Okay, so the first point, the standard specifies is each layer what service they are going to provide to the lowest layer. So for example, application layer, what service it is going to give to the presentation layer. Presentation layer, what service it is going to provide to the session layer. Session layer, what service, okay, is going to provide to the transport layer. Similarly, each layer should be clear that what service they will get from the upper layer. So this is the first specification. The service access point provided, sorry, I forgot to highlight this. So the service access point provided and required from the lower layer. So each layer, what service they are going to give to the lower layer, and also what service they require from the upper layer. Okay, so application layer, what service it is going to give to the presentation layer, and presentation layer, what service it is going to get from the application layer. So this is defined this is specified by the standard. So please understand, if someone provide any protocol, then they have to satisfy the rules here. And also the second point is related to the first point, what functions they are going to provide. For example, students, there are different protocols. Already I have told you, example HTTP, TCP, okay. Then you have ARP, address resolution protocol. Then you have ICMP protocol. Okay, so what function these protocols are going to provide? For example, ICMP protocol, when there is any error in the network, ICMP protocol is used to relay the net error message. Okay, IP is used for routing, TCP is for transporting. Okay, so HTTP for web communication. So what function these protocols are going to provide, that will be defined in the standard, so they have to follow that standard. Clear? Next point is the protocol including the format of the packets and each field with packet the headers. So the point here is so whatever protocol you are going to define, you should specify the structure of the packet. For example, see here, for example, students, this we will discuss many times in this lecture. So you have application layer, okay, then session, session, transport, network. Okay, so here the data, when it comes to the transport layer, okay, so it would be like this. You have a TCP header, example, if TCP protocol is used. So there are two protocols are there according to OSI, TCP or UDP. So you have the data here. Okay, so this we call this as segment. And when it comes to the network layer, you have IP protocol header is attached. Then you have this TCP and then you have the data. So please understand here, this is called payload, and here this is called as payload. So here when it comes to the data link layer, please understand you have something called frame header, then you have the IP, then you have the TCP, then you have the data, then you have the frame trailer. So here this one is the payload. So please understand, so whenever the packet sorry data come to any specific layer, the protocol header has to be attached. The protocol header should, it has various informations like TCP header. If you take, what is the source port number, what is the destination port number. Here IP, if you take the IP, you know what is the source IP address. Okay, what is the destination IP address. Here in the frame header, what is the source MAC address, what is the destination MAC address. So now you can understand. Okay, format of the packet. Okay, in each layer, what is the format of the packet. Okay, then if you take the headers, in each header, what are the different fields that exist. I gave the clear example. For example, if you take the TCP header, you have many fields, but very important fields are source port number and destination port number. And in the IP header, source IP and the destination IP are the important fields. In the MAC header, source MAC and destination MAC is the important fields. So these informations has to be specified in the headers, and also the time factor and the sequence of the packet should be specified. Please understand, when the packet is transmitted from one end to the another end, okay, there is a sequence, packet sequence number. And okay, so when it reaches the destination, it would be arranged according to the sequence number, and then it would be sent to the upper layer. Okay, so the time factor and the sequence numbers has to be clearly established. It should be defined. So students, these are the important elements that the standard specify. First one, service access point provided, okay, and required from the lower layers. See what service the upper layer is providing to the lower layer. Okay, then what service the lower layer wants from the upper layer. Okay, that is the first point. Second point, what function this particular protocol is going to provide. So I give many times. Okay, so different protocols provide different functions. Next one is the protocol including the format of the packet. So please understand, the packet, the data has to be encapsulated by some headers when they come to each layer. Example, TCP header, IP header, frame header. Okay, and each header they have specific fields. Please understand, specific fields within the header. If you take the TCP header, source port number and destination port number are important fields. So these fields should be defined, and also the timing and the sequence of the packet should be defined. Is it clear to you? So these are the standards set, rules set by the standard committees. Students, am I clear? You have any doubt? Can I proceed? Students, first of all, are you there or not? Students, are you all in the college or in the hostel? Okay, Moomin, are you there, Moomin? Mr. Moomin. So you understand this slide, students? What is the standard? Asal Abdullah. Okay, good. Okay, next topic what we are going to discuss. Okay, the standards we discussed here, and which organization is responsible for these standards. Okay, now there is many organizations out there, no single organization, there are many organizations. Okay, so here what you have to do, students, you need not memorize them, just know the names of the organizations. ANSI, okay, is an organization. Then IEEE is a very important organization. ISO is another organization. ITU T is another organization. IETF is another organization. American National Standard Institute (ANSI) is a private organization. Okay, many professional societies, government, they are part of this. So they developed many standards. So try to understand, no need to memorize. Okay, ANSI. IEEE is very important organization related to the many standards and protocols developed. Okay, then ISO. This ISO is very important. Why? We discussed about the this OSI layer. This OSI layer actually came from the ISO. Clear? A group whose membership is standards community from across the world. ANSI represents United States on ISO. So the ISO organization, please understand, they are the one who developed the this OSI layers. So ITU is for telecommunication. So okay, now we have mobile communication. Okay, so they are related to the telecommunication. Other than this, there is nothing to memorize here. Is it clear, students? Please remember the names. Okay, am I clear? Students? Okay. Now we are going to discuss, compare the TCP/IP and OSI layers. Please, you should remember the TCP/IP layer and the OSI layer. So what are the different layers in the TCP/IP? So can you tell me, students? Now this is OSI. What are the layers in the TCP/IP? We discussed in the first slide itself. So application, okay, transport, then network, then data link and physical. So please understand TCP/IP has 5 layers. In the transport layer, please understand there are 2 protocols as far as OSI is concerned, TCP and UDP. But as far as the TCP/IP protocol is concerned, in the transport layer, only TCP protocol is there. In the network layer, IP protocol is supported. So do you understand the difference between OSI and TCP/IP, students? Can you remember this? Students? Yeah, you must remember this OSI and TCP/IP. You should compare them. Okay, this is important. Students, finally, you can go here, click download as PDF. You see, I click here. Okay, I will get a PDF. Okay, so you also can do that. You will get as a PDF file, or you can save from image. You have 2 options. So in this slide, students, we are just comparing the TCP and OSI layer. Already I have given that. Okay, so once again they are also giving here. So TCP application layer. This is the transport layer. In the transport layer, only TCP protocol is there in the TCP IP layers. Then this is the network layer, IP protocol, data link layer, physical layer. This is the OSI, application, presentation, session, transport, network, data link, and physical. Okay, students. So when your data starts from one system, the data will go from application layer to TCP layer, then to IP layer, then to data link layer, and then physical layer. It will be transmitted across the network. When it reaches the destination system, it goes to the physical layer first, then data link layer, then IP layer, TCP layer, application layer. This is how it works in the as far as the TCP IP is concerned. Same thing applies to the OSI also. So OSI layer function reviews. Okay, application layer. We were talking about the functions. Okay, in the beginning, the protocols, they have some functions, specific functions. Like we have the HTTP, TCP, UDP, then we have IP, ICMP. So these protocols, they have some functions. Now let's see the functions according to each layer. So in the application layer, whatever protocol you are fitting into this layer, what functions it should have. So the application layer, it interface between application and the network program. So students, we are using many applications like web browser. Web browser is an application, understand? So when we use the web browser, it's an application layer. So the application, it is application. So the application layer should act as a mediator between the application like web browser, or you have WhatsApp app, or you have any app that you use to communicate across the network. So the application layer should act as a mediator interface, okay, between this application and the network. Okay, first function of the application layer. It supports the application. It has to support the application. For example, you have the browser, okay, we have the email applications, okay, file transfer applications. So these are the applications that would be supported by the application layer. Second one, the presentation layer. The main responsibility function of the presentation layer is it deals with the data. Okay, please, I added this point, note down. This is a very specific points. So what this layer is doing, students, encoding. It will encode the data into a specific format. Okay, there are many encoding techniques are there. So using any one of the encoding technique, it will encode the data, convert the data into a specific format. Then decoding, then compression, reducing the size of the data, encryption. All these functionalities would be performed in the presentation layer. So this is the main job of the presentation layer: encoding, decoding, compression, encryption. Okay, so this is the main function of the uh, uh, presentation layer. Next one is session layer. So the main responsibility of the session layer is to create, manage, and close the connection. For example, now if I log, okay, now students, You are in a session. You are me and you all connected to the Google. So we are in session. So when I click here, uh, when I click this leave call, the session closes. Similarly, now in the middle, if there is a power failure or if there is a network issue, automatically my system would try to connect with the Google Meet. Similarly, your system also would try to connect with the Google Meet automatically. So this is the job of the session layer. Okay, creating, managing, and closing the connection. Session layer job. So whenever any connection is established, see we are best example Google Meet. We are all connecting to the Google server, okay, and we are connected, created. The session connection is created, and it is the responsible for managing. In case any interruption, network problem, it will reconnect, and finally it will close the connection. Okay, so this is the main job of the session layer. The next one is transport layer. The main job of the transport layer is students to establish the connection, providing reliable connection. Okay, please students, I made it easy. I highlighted the points. It provides reliable connection. The transport layer job is to create the connection, reliable connection. And also other important points are students packet sequencing, sending the packet from one computer to another computer. Packet sequencing, putting a sequence number means, for example students, you are sending the packet. Okay, for example, when the packet goes from one system to another system, it will go through different routes, different routers in the network, and when they reach the destination, please understand, before the destination system process these packets, okay, it should be arranged in the same order, sequence number. Otherwise, for example, let's see, whatever data which comes in the front will go reach at the end. Okay, it might reach at the last as a last packet. So this is the job of the transport layer, to sequence the packet and arrange them in a order before it is given to the application layer. So packet sequencing, traffic control, understand, congestion control. Okay, so these are like, if there is any packet not reached, sending it again. Okay, so these are the responsibility of the transport layer. So be specific students, very important. Providing reliable connection, packet sequencing, traffic control, and congestion control. These are the functionalities or functions of the transport layer. In the transport layer, there are two important protocols. One is TCP, another one is UDP. Next one is called network layer. Network layer, the important protocol is IP. So this layer is responsible for routing device independent packets. See, when we are communicating across the network, see, I am speaking now. You are able to hear the my speech, voice, as well as you are able to see the screen, my system screen. You understand? Okay, so these packets, voice and image, they come to you. Okay, this travel through the network, different networks, and they reach you. So how it is possible? They have to pass through different routers. Okay, so this is called routing. Okay, so this layer is responsible for the routing. Okay, so there are many routing protocols are there which you will study, like RIP, EIGRP, routing protocols. Okay, so these network layer supports these routing protocols. They route the packets across different networks, and of course it is device independent. It does not dependent on any device. It can go through any device. Some routers are Cisco, some routers are Juniper, some routers are Huawei. No problem. Understand? So this network layer is responsible to route the packets, yani send the packets from one network to another network, okay, in a device independent manner without depending on the device. Okay, so hop to hop means, please understand, from one network to another network, from one router to another router. Okay, so the main job of the network layer is routing. That's all. Routing the device independent, okay, in a device independent manner, routing the packets from one router to another router, from one network to another network. Data link layer, students, actually you see the network layer device independent, but in the data link layer encapsulating device independent data packets into device dependent data frames. So the packets which come from the network layer goes to the data link layer. Okay, so they are encapsulated by the data frames. Okay, so the data frames are okay, they add the MAC address, source MAC address, destination MAC address, and they send the packet frames within the local area network. Once again, this layer has two sublayers: logical link control and media access control. There are two layers on there. Okay, students, here again go back. See here. So the data come to the transport layer, the TCP header is fixed. So when the data come to the network layer, IP header is fixed. Okay, so when the data come to the data link layer, frame header is fixed and frame trailer is fixed. Frame header will have the source MAC address and the destination MAC address. Okay, so very important. So please, the packet from the upper layer. Okay, so when the segment come to the network, it is called as packet. So when the packet come to the data link layer, it is called as a frame. Here it is device independent. Here it is device dependent. Okay, this is within a local area network, within our lab, for example. Okay, within the lab, let's say. Okay, the frames are distributed within the local area. Within our college network, the frames are distributed. This is across the wider network. You understand? So this is packet, segment, packet, frame. So let's come back. Responsible for encapsulating the device independent data, that is packet, into data frames. Okay, so packets are converted into frames. The packets are converted into frames in the data link layer. Once again, the data link layer has two sublayers. One is logical link control, and media access control. Logical link control, media access control are the sublayers of data link. So you have to be very strong, students, regarding these layers. Don't miss any one of the points which I am giving. Okay, so please understand, when the data come to the transport layer, it is encapsulated with a TCP header or UDP header. So it is called segment. The same segment, when it comes to the packet, it is encapsulated, it is added, attached with the IP header. So it is called packet. When the packet come to the data link layer, please understand, okay, frame header is attached and the frame trailer is attached. And data link layer has two sub layers, logical link and media access control. Now finally, when the frame come down to the physical layer, okay, the frames are the frames transmitting the device dependent frames, the frames are transmitted through some physical media, wireless media or wired media. Understand, we have ethernet connection, we have wireless. Okay, so the frames will be converted into a data format according to the physical media, and they will be transmitted by the physical layer. Is it clear to you? Am I clear, students? So here the physical layer, once again, it can be wired or wireless. Is it clear to you? So the frames will be converted into the format according to the type of network, like wired or wireless, and the data will be transmitted across the medium. Okay, whether it is a wired medium or wireless medium. So please understand, students, these are the different layers and their functions. Let me give the brief recap. So application layer means it is the interface between application and network program. It supports the applications. Then the presentation layer, it deals with the data formatting. You can tell data formatting also. What is the data formatting? Encoding, decoding, compression, encryption. These are examples. The session layer is responsible for creating, managing, and closing the session connection. Actually, to be specific, session connection. Okay, the transport layer is responsible for providing a reliable connection with functionalities such as packet sequencing, traffic control, and congestion. Network layer routing the packets, okay, from one hop to another hop, from one network to another network, or one router to another router. Data link layer, please understand, the packets are encapsulated into frames. Okay, it has two sub layers: logical link controller, media access control. Then physical layer, please understand, the frames are transmitted across some physical medium, wired or wireless. Students, any doubt? Am I clear? Students? Next one is, already we have all these points we have finished actually. So application layer, students, so don't memorize anything, don't memorize, I'll just tell you, already we have discussed. At the application layer we have, we from application layer we get the data. The data, when it goes to the TCP layer, or we can say transport layer, TCP header is attached, this one. See, already we have discussed this point. From application layer, okay, you get the data. So you have the application layer, you have get the data. When this data go to the TCP layer, please understand the TCP header is attached. Already we have discussed this. TCP header is attached. Okay. See, TCP header is attached. When the data goes to the the transport layer, if the TCP protocol is used, the TCP header will be attached. UDP is another protocol. You have choice. For example, students, sometimes TCP will be used, sometimes UDP will be used. For example, if there is no connection between the two system, like we are watching a video, okay, like football match in the YouTube, that time UDP protocol will be used. Okay, if there is a connection, like now we all are connected to each other, then TCP protocol will be used. Okay, so please data when it comes to transport layer, TCP or UDP header is attached. Then it comes when, okay, it is called segment. Please understand, it is called segment. When it comes to the network layer, IP header will be attached. It is called packet. When it comes to the data link layer, frame header will be attached. It is called frame. So same thing is given. Okay, application layer produce data. Data when it come to the TCP layer, TCP header will be attached. So TCP seg packet, or we can call it as segment also. Okay. When the TCP packet or segment, when it come to the IP layer, okay, we get IP packet, okay, or we can call as packet, simply as a packet. Now, okay, so you can see here there is a IP header, there is a TCP header, and there is a data. Clear? Now, when this goes to the data link layer, okay, we call it as frame. Okay, so it has a frame header and frame trailer. Then that other things, IP header, TCP header, and the data, real data. Now this will be sent to the physical layer. So this physical layer convert this frame into a sequence of media signals. For example, wireless means it will be transmitted as radio waves. Understand? Or if it is sent to the through the Ethernet cable means it will be converted into binary bits. Okay, it depends on wired or wireless connection. So this is very important. I hope you understand this. Clear now, students? Segment, packet, frame. Is it clear, students? Okay, good. Okay. So please understand, don't memorize this. Just try to understand this diagram. Will you do that? Can you do this diagram, students? Students, can you understand this diagram? So please don't memorize here. Whatever here it is explained here. Okay, only one thing is important here. A frame has a header and a trailer. The frame, let's say Ethernet. Ethernet means wired connection. Okay, and sequence of media signals for physical layer. That is, physical layer will convert the frame into media signals. So there can be a multiple choice question. Okay, physical layer convert, okay, convert this frame into media signals. And the frame, please understand, it contains the frame header and frame trailer. The another name for frame trailer is CRC, cyclic redundancy check, to check the integrity of the data. The size is 32-bit. Okay, so students, here IPv4 32-bit in the network layer, or IPv6, it can be used, that is 128-bit, and frame header as MAC address, that is 48-bit. Okay, TCP header has the port number, that is 16-bit. So you should know all this. We will be discussing that now shortly. Okay, next one is crypto placement at different layers. Crypto means, students, cryptographic algorithm. So cryptographic algorithm means it is used, I again repeat, you can download as PDF. Only two students connected. One is Dana Al Nubi, another one is Saja. So students, now cryptographic algorithms. So when a system wants to securely connect with another system, you need authentication, then you need confidentiality. So confidentiality can be given using encryption. So students, you need confidentiality and you need authentication. So you have to, this is, let's say A, let's say this is B. So when A is sending to B, okay, it should authenticate to B and B also should authenticate to A. Then only, there will not be any spoofing. So each other, they have to be sure that they are talking to a genuine person. Authentication. So there are many types of authentication techniques out there. And also when the A sends some data, B sends some data, it should be encrypted. So somebody in the middle, okay, they should not be allowed to do MIM attack, when in middle attack. Okay, spoofing, replay attack. They should not allowed to capture the packets, eavesdropping, nothing should be allowed. So you should have a strong authentication and strong confidentiality. Okay, so for that we need cryptographic algorithms. Okay, and for example students, we can go for SSH, SSL, IPsec, understand. So these are some of the security protocols. They support authentication, they support confidentiality. Okay, if there is authentication and confidentiality, we can protect the communication from different attacks. Okay, so now the point is we have many layers like application, okay, session, okay, presentation, okay, transport, network, data link layer, physical layer. Now in which layer shall we put this? These are algorithms, right? Cryptographic algorithms. Where shall we put them? Here in the application layer, or in the transport layer, or in the network layer, or in the data link layer? In which layer shall we put these cryptographic algorithms? Cryptographic algorithms, please try to understand students. Let's for encryption, students, encryption, okay, we can go for symmetric or asymmetric. Symmetric means, okay, AES encryption algorithm, DES, okay, RC6. This is asymmetric. Asymmetric means RSA, DSA, okay, Diffie, Hellman. So these are the examples of asymmetric cryptographic algorithms. Okay, so the point here is, now we have different cryptographic algorithms. Where shall we put them? Okay, so in the application layer, or in the transport layer, or at the network layer, or at the data link layer. Okay, so that is the question. So suppose if you do at the application layer, okay, what happens? So you can fit the encrypt security at the application layer. That means you can encrypt the data. So you can encrypt the data at the application layer. Okay, otherwise, so for example, when you do like this, what happens? You encrypt here and send to the transport layer. Once again in the TCP header, okay, you encrypt here, you can encrypt here. Okay, in the IP you can encrypt like this completely encrypted. Okay, for example, in the data link layer, if you do frame data link layer, if you want to do, it will happen like this is encrypted. Okay, so the point is the cryptographic functions can be implemented at the application layer or the transport layer or the network layer or the data link layer. So at the application layer provides end-to-end security protection. Data is encrypted or authenticated at this layer. Please understand, security involves both encryption and authentication. I told you authentication means proving the genuineness of a entity. So when we are talking to each other now, you should be sure that Shimas is talking here, and also I should be sure that so and so student is there. That is called authentication. So when you encrypt at the application layer, the encrypted or authenticated data go through the layers below, okay, without decrypting or checking their signature. So when you encrypt at the application layer, please understand the encrypted data goes to the layers below. So the layers below, they don't decrypt, they don't do any verification, signature verification. Okay, so the encrypted, you encrypt at the application layer itself. So when it goes to the destination system at the application layer, it will be decrypted. Okay, so the point is in the application layer also you can fix the encryption. Am I clear, students? Hello, students, am I clear? So the encrypted or authentication data goes through the each layer, goes through each layer without decryption. I'm making it simple for you. Please, wherever I highlight, you try to note down, or I send this PPT to you now after the class. So it is easy to prepare for the exam. So next point is the encryption or authentication can be done at the transport layer also. Okay, so if you do the security at the transport layer, it provides security for TCP packets or segments. So crypto placement, the payload of TCP packet or the entire TCP packet can be encrypted. Okay. So payload of the TCP packet or the entire TCP packet encrypted or authenticated. So what it means? See, students, this is payload. I told you already. I told you payload. So anything before the header is payload. I told you, no, here this is the payload. So anything, this is the header, TCP header. Anything before the header is payload. In the network layer, IP is the header. So anything before this IP header is payload. Here, this is before the header, right? So this is payload. So in the data link layer, this is the payload. Okay, students. So when the application layer produce data, when it comes to the TCP layer, Okay, so this data is attached with the TCP header. So this data what is attached with the TCP header, this data is called the payload. Okay, so this can be encrypted. Is it clear to you? And authenticated. Okay, encryption and authentication can be done by some security protocols. It will do both the purpose. So that can happen in the TCP layer. So if it happens in the TCP layer, please understand that security is provided at the provided for the TCP packets. Okay, so please provide security protection for TCP packets. Payload of a TCP packet encrypted or authenticated at this layer. Okay, so this is important point. The network layer. So similarly, you can do the protection at the network layer. Provides link to link security protection. So students, I expect you to know this. Provide end-to-end security protection. This also you note. Why? Because it can be a multiple choice question. In which layer? Providing crypto placement in which layer can provide end-to-end security? So the answer should be application layer. Similarly, if you come here, okay, so provide security at link to link level. It is provides link to link security. Okay, when you provide the crypto placement in the network layer. Okay, so it can be a multiple question, so please note down this. Okay, so when in the network layer, what exactly happens? The payload of the IP packet or the entire IP packet can be encrypted or authenticated. Applying cryptographic algorithms, it does not affect routing. This is important. Just remember this enough. Okay, this is enough, students. Now I will explain. So, students, see here. So now the TCP packet or the segment, when it comes to the IP layer, this is called IP packet. So here, please understand, this can be this payload. This is the payload, right? This payload can be encrypted. Can be encrypted. Okay, this is one option. Okay, another option is, please understand. Okay, the second option is you have the IP header. Okay, then you have the TCP header, you have the data. Okay, so please understand, um, this is called payload. This is called payload. Okay, this is payload. So here this payload can be encrypted. That's the first option. The second option is, please understand, the entire IP packet, including the IP header, will be encrypted. It will be encrypted. And if this entire is encrypted, please understand, okay, new Jadid IP header will be attached. This will not be encrypted. Okay, let me change the color. Okay, so this will not be encrypted. A new IP, because if the IP header is encrypted, please understand the packet cannot be routed. So they will fix a new IP header. This is called tunnel mode. This is called tunnel mode. Okay, I don't want to go deep into this because it would confuse you. So if there is a security, okay, example VPN security, understand, then the tunnel mode can be used. So in the tunnel mode, please understand, the entire IP packet is encrypted and a new IP header is attached. Clear? In this is second option. In another option, for example, transport security. Please understand. Only the payload will be encrypted. The IP header will be not touched. It will not be encrypted. This is first option. The second option is including the IP header, the entire IP packet will be encrypted and a new IP header will be attached. If if we are using tunnel mode, example VPN, virtual private network. Students, is it clear, students? Very important point, students. Can you understand this? If you have any doubt, ask me, please. Okay. So in the network layer, please understand, provides link to link security between network layer to network layer security. The payload of the IP packet, or this is the first option, the payload of the IP packet, first option I explained you, or the entire IP packet encrypted or authenticated. It does not affect the routing. Please understand, it does not affect the routing. Okay. So there is a, please understand, a tunnel mode option is used. If the tunnel mode option is used, please understand, the entire IP packet will be encrypted and a new IP header will be added. Okay, for example, students, when we are using VPN, you know VPN, virtual private network. Okay, what happens if we are not using VPN? Let's say we are using Skype. It is blocked by the Omantel ISP provider. Example I'm telling. Okay, so suppose if the country law permits, okay, then we can use something called VPN. If the law is not allowing us to do, we should not do. Okay, so suppose if VPN is used, what happens? The entire IP packet will be encrypted. A new IP header will be attached. So what happens if the IP packet is encrypted? The ISP provider cannot read the content, firewall content. Understand? So that's why the VPN is a best example for tunnel mode. So students, let me do the recap of this concept. The crypto placement can be done at the application layer. It is called end-to-end security. It can be done at the transport layer. So it would protect only the TCP packet. Or it can be done at the network layer. It is called link-to-link security. So when it is done in the, please understand, application layer, data is encrypted or authenticated at the application layer. So the encrypted data go to the layers down. The layers down, they will not do the decryption. It will happen in the destination system only. So please, if it is the crypto security is provided at the transport layer, please understand the TCP packet. If it is done at the transport layer, please understand the TCP packet or the segment is encrypted or authenticated. Okay, I mean the payload of the TCP packet is encrypted or authenticated. At the network layer, please understand, it's a link-to-link security. The payload of the IP packet, or sometimes the entire IP packet, tunnel mode, encrypted or authenticated. It does not affect the routing. Tunnel mode is used for when the entire IP packet is encrypted, the tunnel mode is used. That's all. And also the security can be provided at the data link layer. So it provides security for frames. Okay, so payloads of the frames are encrypted in this layer, very important. Okay, we note the frames travel only the traffic analyzing will not yield much information. Okay, so please students, here when you fix the encryption or authentication at the data link layer, please understand. Okay, so the payload of the, okay, the frame, okay, will be, this is the payload, this is frame header, this is the frame trailer. The payload will be encrypted. Okay, so it will protect the frames. Okay, now it will not affect the application layers, any applications. It doesn't affect, because we are implementing the security at the data link layer. It will not affect the applications. So the provide security protection for frames. Payload of the frames, payload of the frames are encrypted or authenticated, does not affect the application programs. So far I have discussed where exactly the cryptographic placements can be done. Okay, students, for example, you want to configure VPN from your office. You want to configure, you want to connect the different branch offices. Okay, you want security. You want to connect the different networks of different offices, Sur, Muscat, Salala, okay, of a company. So if you want to provide security, let's say I give one example, IPsec. So if you use IPsec, it will provide the security at the network layer. Okay, so for example, so there is organization Muscat. There is an organization at Sur. Okay, Salala. Then okay, Suhar. Okay, they have branch office. So what you can do is you can you can connect them. Let's say there is an internet, so you connect all the branch office through the internet. So you can configure IPsec, 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 IPsec. Through the IPsec protocol you can connect them through the tunnel mode. Okay, so there is authentication, there is encryption, and the security is provided at the network layer. The security will be protected given at the network layer. So I am giving one example. Okay, suppose, okay, you are accessing some website, secured website, example Bank Muscat or Instagram. Okay, so from between our system browser and the Bank Muscat, okay, so the security will be provided using TSL or SSL, application layer. Understand? Secure socket layer. So please understand, there are many security algorithms are available. They work in different layers. So that is what we discussed so far. Next one is students. Students, are you following me? Students? Okay, 11:40. I take the attendance now. Remaining part algorithms can be implemented using hardware or software. They can be implemented at the hardware level, or they can be developed and implemented using a software. Okay, cryptographic algorithms implemented on hardware using application specific ASIC technologies, integrated circuit technologies. Okay, so that means in some systems the cryptography is supported at the hardware level. Cryptography means encryption, decryption, authentication. These mechanisms can be supported by hardware level embedded programs. Okay, and also it can be implemented using
software. So it is common to implement cryptographic algorithms at the application layer. So if you want to implement the cryptographic algorithms at the application layer, you will go for the software, and at the data link layer the hardware technologies are preferred. So other layers like transport layer or the network layer, either of the both technologies can be used, that is hardware or software. Okay, when you ask about their performance, to compare their performance, the hardware implementation has a better performance, but they are not flexible for any change. It is not to change the algorithm, it is not update them, because they are at the hardware level, embedded programs are used, and porting to different platforms. Okay, so fitting this hardware in different devices is not flexible, and also the cost wise it will be more you have to spend to develop and implement. So hardware implementation means better performance, but the drawback is inflexible, not flexible for change. And also another disadvantage is hard to port. That means fitting on different hardware devices, and also the cost might be more compared to the software. But the software actually they are they are flexible for any change. We can change, update them, okay, and also we can implement at different hardware levels in different systems, mobile, laptop, desktop, servers, any device it can be implemented, and also the cost also less. So these are the two differences, students, between the hardware and the software cryptographic implementation. So you can see a possible short answer question: what is the difference between the implementation of cryptographic algorithms at different layers, and what are the cons and pros? Okay, benefits and disadvantages. Now next we are going to see about the protocol addressing. Now when a user wants to communicate with another user in the internet, how the data is transmitted? So the user connects the service provider. Example, we connect from our home, we connect with Untitled ISP provider. Just think like that. Your friend is in Emirat and he is connected with Etisalat. Okay, he or she connects with the Etisalat in Emirat, and you are in Oman, you are connecting with Omantel. Okay, so when you have a network connection, please understand, okay, you will get a IP address. So you will get a IP address. Okay, IPv4, IPv6, there are two types of address. IPv4 means 32 bit, IPv6 means 128 bit. So every computer in a network has a address. So when we connect with the network, we get address. So these addresses, students, can be okay, so IP address v4, IPv6, okay, so IP private address and public address. So private address means a address allocated by a DHCP server within a local area network. Okay, and this one public address is assigned, this is allocated by the ISP provider. For example, in Omantel, from the Omantel you can get a public address. Suppose you have a website, you are running this website in your system, and you want you know people in the network to access the website, then you should have a public IP address. Clear? So the public IP address from where you can get from the ISP provider. So the important information is every computer in the network has a address. Without address, a system cannot communicate with another system. Address from the header to determine whether where to send the next where to send the message. Okay, so when you are using, for example, you are sending an email. Okay, so this some message you are sending that has to reach this destination. So what happens? Okay, so for example, you are sending some message that has to reach this system. So what will happen? Okay, the message, along with the message, we have seen in the previous slides that a header will be attached, IP header. Okay, so in the transport layer, TCP or UDP header, in the network layer, IP header will be attached. The IP header will have what is the source IP, what is the IP address of this system, what is the destination IP, IP address of this system, that information it will have. So when this data along with the header reach the ISP provider, it will send across the network, okay, to the appropriate recipient service provider, internet service provider, that is from Omantel. From the destination IP address, it knows, okay, through which path it has to forward the packet, so that the packet will reach the recipient, okay, ISP provider, Emarat is example Etisalat. So when the recipient internet service provider receive the packet, based on the IP address, it knows where exactly this packet has to be forwarded. It all depends on the IP address, source and destination IP address. So it will come to the recipient. So every computer has an address. The application take the message from the user and will read the destination recipient. So address from the header determine where to send the next. Okay, so the address is very important. So address where you can find in the header, IP header. So based on the address, okay, the internet service provider, sender, source service provider forward through the optimum path, best path through the recipient ISP, and recipient ISP send to the recipient. So what you understand from this slide, address is important. Okay, there are many addresses. Okay, this is the IPv4 header. Students, this actually there are three headers. This one is IPv4 header. This one is TCP header, and this is called frame header. Okay, let me give the name, otherwise you might get confused. So this is IP header. Okay, this one is TCP header, and this one is frame header, Ethernet frame header. So this works in transport layer, this works in the IP layer, this works in the data link layer. Clear? So here you can see in the IP header, there are many fields which we are going to discuss. The important two fields are source address and destination address. So based on that only, the routers in the network, they know where to forward the packet whenever they receive any packet. Okay, where exactly it has to be forwarded, that is decided using this source and destination IP address. They are available in the IP header, and the TCP header actually has many fields, but the important two fields are source port number and destination port number. And the important fields in the frame header are source MAC address and the destination MAC address. Source and destination MAC address. So these are the addresses about which we are discussing. Clear? So protocol addressing. So when the sender sends the packet with the header, the ISP will read the header and it will determine and send the packet, okay, to route the message. That means it will send the packet through the internet through the best path. There will be many paths available. So how can I say? So from this system, if you want to send a packet to this system, it can go through many paths like this. You see, these are the routers in the network. You have many options. Like if you want to go from Sur to Muscat, you can go through Kuriyat, or you can go to Ibra, Nizwa, you know that route. You understand? So you have many routers in the middle. So this packet has to be sent to this destination through which router? Okay, that is the question. So they use routing protocols. The routing protocols are used to find the best path. So through the best path, they will forward the packet. So the routing protocols help the routers to decide through which path the packet has to be forwarded. When you have multiple options, you have to settle with one solution, right? The best solution. So the router, they will use the source IP and destination IP. So now the question for this router, you have many options. Which option to select? Okay, so they use the routing protocol and decide which is the best path. Okay, so ISP will read the header. So when the packet comes from the sender, it will read the header and it will use the routing protocol and decide, okay, which is the best path to forward this packet to the recipient ISP provider. So ISP will send the message into the internet, routed. Okay, the packet will be routed. Any routed means what? You see, it will go from one hop to another hop. From here it reach, this is one hop, two hop, three hop. So it moves from one router to another router, okay, until it reach the destination. Okay, so ISP will send the message into the internet. So internet will have many routers, okay, and the packet will be routed until it reach the destination. So each router will use the routing protocol to decide which is the best path to forward to the destination. So finally the message reaches the destination computer. Now here, when it reaches the destination computer, once again another problem comes, because in the destination computer there will be many programs running. So to which program this packet has to be handed over? Okay, let's say there are many families in a building. To which family the parcel has to be delivered? Okay, for that In each and every system, if many applications are running, these applications are if these applications are network based applications, they are assigned a application address that is called port number. So application address, okay, is nothing but port number. So the port number helps the system to determine to which application this packet message has to be handed over. Okay, students, so we will discuss that about that. So network address, okay, then also you should know what is a port application address. Another name is port address, port number. So we have many layers: application layer, transport layer, network layer. Okay, so we have data link layer. So there are many layers. Okay, so for the communication, the many layers are needed. So how the address, okay, once again let me give a recap of these addresses. Please understand, at the network layer, IP address is used. This IP address is used to send packet from one router to one machine to another machine. Is it clear to you? So based on that, okay, routing protocols are used to determine which is the best path. So this is network address, IPv4 or IPv6. Clear? Second, application address or port number. This is to identify which application in the system the message should reach. So it is decided by the port number. So the sending application also will have some port number, and the destination also will have some port number. So the sender should know what is the port number of the destination application to which this data has to reach. Okay, then once again in the local area network, okay, when a message has to reach the specific computer, you need something called MAC address, the address of a machine, physical address. Okay, this is MAC address or 48 bits. How the address are assigned? Static assigned, dynamic. That means if we manually configure the port number or the IP address, it is called static configuration. Suppose if it is done automatically by some service, like IP address automatically given by DHCP server, or like port number is assigned automatically by the operating system or by some application, it is called dynamic. So the address like IPv4 or IP address or the port number can be configured statically or by dynamic way. Who's assigned the address? Central authority. For example, when you want a public IP address, I told you, when you want the public IP address, okay, you have to get from the ISP provider. Example, in Oman, okay, Omantel, okay, you have to pay money and get public IP address. So central authority. Locally based means, please understand, private IP address. So private IP address 192.168.1.40. For example, you check your device in your home, mobile phone or your laptop, you will get some IP address from the Omantel or Ooredoo router that is assigned by a DHCP service. This IP address is called private, not public. This is allocated by your Omantel or Orido router. Inside that there is a DHCP service running that allocate this IP address. This is valid within the local area network within your home Wi-Fi. Clear? This is private. Then this one is called public. Public IP address is allocated by Omantel. Clear to you? Once again, when you want to send a message across the network here, okay, it should have the public IP, not private IP. In the internet, if you want to transmit the message across the network internet to a destination, it should have the public IP. Okay, so how this is possible? Please understand NAT service. So NAT, what it does, it map, translate private to public. Okay, so the NAT service will be available, okay, in any organization. Even in our home routers there will be a NAT service. So that will have some public IP address that will translate our private IP which is available in our machine to the public IP. Okay, then only our packets can be transmitted across the internet. Physical address. So what is a physical address, students? MAC address. Okay, in our system we have MAC address. Okay, physical address. Okay, this address is not allocated by us, it is allocated by the company which produce the network interface card, NIC card, in our laptop or in our mobile phone. There is a network card. In that network card there will be address. That address, okay, is a physical address. It cannot be changed. It comes with the machine. So the manufacturer, the vendor would implant this address into the device when the vendor is selling the network card. So physical address is vendor assigned. So we cannot change or we cannot allocate the address. It is vendor assigned. So it's a filter to accept the packets by the device. That means in a local area network, if you are sending a message from one computer to the another computer, how it reaches a specific computer using the MAC address. Okay, so any device, when any frame come to it, it will accept the frame only when it has its MAC address. If the frame has its MAC address, then it will accept. For example, someone is bringing the parcel to you. You will take the parcel only when it has your address, house address, flat address. Suppose in the parcel, okay, there is no address of you, there is no phone number of you, there is no your home address. You can clearly see this is for another person in the next building, then you will not take, right? So similarly, each and every system, they will accept the frame based on the MAC address. So that is called filter to accept packets by the device. So please understand, in the network layer there is a protocol called ARP, Address Resolution Protocol. So when a system knows the IP address of another system, okay, it has to find the MAC address, then only it can send the frame. So what it will do, for example, here the system A, let's say system B, this is the IP address. Now it wants to send a message. Now it wants to send frame, frame. to send the frame within a local area network, it needs destination MAC address. Destination MAC address means B MAC address. Let us say A doesn't know. So what A does, it will use a protocol called ARP. Okay, so it will use this protocol. Okay, it will let's say this is the protocol. For this protocol, it will give the IP address of the system B. The ARP protocol, what it does, it will give the MAC address of the B to the A. So now A has the MAC address of B, and now using the MAC address of B, it will construct the frame and send the frame to B. Without MAC address of B, A cannot construct the frame. Okay, so this is the third point. Network layer uses a address discovery protocol, example ARP, to find the hardware address. So using the IP, this ARP can find the MAC address. IP address, as I said already, global address allocation. The ISP providers, okay, they allocate the IP address. They once again get the IP address from another central organization. Okay, so this is called public IP. So no two people can have the same public IP. Within a local area network, students, we can use DHCP server to allocate the IP. For in your Untitled router or Ooredoo router, you are not giving any IP to your laptop. Clear? What you are doing, you are just connecting your system to the Wi-Fi. Automatically Wi-Fi router give the IP to your mobile phone, to your laptop, using DHCP server. Okay, or sometimes you want to set up a local network with 2 or 3 computers, and you want to configure manually the IP address. So that is called static configuration. Next one is the application systems are identified in a system. Many applications which are network based would be running. How to identify them? Using a port number. Clear? So the port numbers, please understand. Well known, they are classified into 3 categories. Well known port numbers are from 0 to 1023. Registered port numbers are from 1024 to 49151. Dynamic ports are from 49150 to 65565. So please understand. So these are the ranges of different port numbers. Okay. So well known port numbers means, for example, web application. So if you are running any PHP web application, the default port number for any web application, web server, is port number 80. Similarly, for FTP protocol, the default port numbers are 20 and 21. Clear? So for each and every network based services, there should be some port numbers. So they are classified into these 3 categories. The total number of port numbers are 65,565 port numbers are there. 566 port numbers are there. Okay. The port numbers, basic purpose of the port number is to identify a specific application. Okay. For example, let's say A, B. So A is sending a message to B. So it reach, okay, there is C, but it will reach the B how? Using the IP address and MAC address. Understand? It will reach the B. So let's say in the B, okay, you have web program running port number 80. FTP program is running in port number 20 and 21. Okay, so you have so many programs with different port numbers are running. Now the question is, you are sending a message. This message should be given, it reached the B using the IP and MAC. Now to which program this message should go, web or FTP? Okay, so what you have to do, in the TCP header or UDP header, you should specify, clear? Sorry, in the TCP header you should specify the destination port number. So the destination port number you have to specify. If the destination port number is 80, then this message will go to this program. Suppose if the destination port number is 20, it will go to this program. So this is the application address, port numbers. Okay, port number basically okay, is classified into three categories. Okay, so basically it is used to identify okay, used to identify the application in a system. So once again, another very important thing which you have to know is, each and every computer, they have a name, computer name. Clear? For example, okay, so you can see the computer name, desktop. Okay, this is the computer name. Okay, if you want, you can change the computer name here. Clear? So this is called host name. So this is also one of the way to identify a computer, host name. Host name can be assigned by a central authority. That means you can use a server. Okay, host server, host name server, that will assign a name to each and every computer in the network. Okay, or you can manually change the name. Now I showed you the option, computer name, right click, properties, you can change. So you have both the options. It can be assigned dynamically by some servers in a large network, in organization, colleges. Okay, now how to identify? For example, you have the computer name of a now see this scenario. So let's say this is system A, this is system B. So the okay, so two systems are here. So this is the host name. So this is the host name. Okay, so now 192. Okay, so they have IP address. Okay, now this system wants to send a message. Okay, but this system, okay, I know host name B, but don't know its IP. So A knows the host name, another computer name it knows, but it doesn't know the IP address. So it needs IP address, no, to send. So what it does, there will be a DNS server, local DNS server. You can configure using Windows or Linux. Okay, so it will send a request. Hello DNS server, can you give IP of B. Okay, so it will check its database and give B IP is B IP is 192.168.1.20. It will give the IP. So using the IP, A will send using the IP again. It will try to find the MAC address using ARP protocol. Then using the MAC, it will send the frame within a local area network. If across the network, then it has to use only the IP address. Okay, so assigned via central authority or local also you can add, or local manual. DNS protocol is used to map the host name, any computer name, to IP address. So protocol headers, students, these are the protocol headers. This is the TCP header, this is the IP header, this is the frame header. Okay, so the protocol headers can be classified into two types. One is fixed, another one is free form. Why fixed means, please understand, if you take the TCP header, IP header, frame header, these are the fields. Okay, for the size is already determined. Okay, 22, for example, IP header 20 to 24 bytes. It cannot be more than that. Okay, so TCP header, there is a specific size. So for example, can I put the source port at the end? Can I put the destination port at the end? Can I put the checksum in the beginning? No, you cannot change. Okay, what is the size of the source port? Port number 16 bits. Okay, can I make it 32 bit? No, not possible. Source IP 32 bit if it is IPv4. Can I change? No, it is not. Everything fixed. So please understand, in the protocol headers are fixed and free form. In the fixed headers, the fields are fixed. That's all. You cannot change their names, you cannot change their values. I mean, you cannot change their size, you cannot change the location. You cannot change the location and size, very important. But another type of headers are there which will be used in the application layer. Okay, these headers are free form. They do not have any fixed format and they are available in the application layer. They doesn't have any fixed format. The fields can change their position, can change their size, but in fixed form headers it is not possible. So please recap of this slide is protocol headers can be fixed or free form. So free form headers are used in application layer, but whereas in the TCP header in the transport layer, or IP header in the network layer, or you see this frame header in the data link layer, they are not free form, they are fixed. So headers are attached, appended, joined with the data. Clear? Already we discussed many times, when the data come to the transport layer, TCP header or UDP header is attached. Once again, if they come to the network layer, IP header is attached. Clear? And once again, when they come to the data link layer, frame headers are attached. The header, once again, okay, has many fields. Some fields are fixed, some fields are optional. Okay, let's go back here. So you can see source port, these green color in the TCP header, these blue colors, okay, at the background, they are fixed, okay, and also you have some space for options in case you want something extra. Similarly in the IP header, okay, you have options and fixed headers. Okay, for example, let's say why we need options. Okay, for example, in the TCP header, if you want to add the timestamp, you know what time this um, segment was created, you can make use of the option field. Suppose you want to add some bits, zeros, to make it a specific size, zeros and ones, just adding padding, that is called, then you can go for option field, window size extension, etc. Okay, so there are some, but I don't want to take more time, but just try to understand timestamp, padding, that is easy to remember. Okay, so uh, so this is fixed part and optional part. So fixed part contain information that is needed to process every packet. Okay, we cannot skip this. Okay, so but optional part is optional. Okay, it is optional, that's all you can understand. Okay, I told you, like timestamp, etc. But fixed part, you cannot skip any fields. Okay, if you ask, like, can I skip the sequence number, can I skip the source port, can I skip the destination port? No, not allowed. Can I skip the source address, can I skip the destination address? No, it is not allowed. Clear? So that is the fixed part of the headers. Optional part are optional, that's all. So the when a packet is when the data is attached to the headers, this is how it looks like. The front side fixed, options, then you have trailers. Clear? So this no need to memorize, students. So freeform packet headers, they are used in the application layer, like when you send HTML data from one system to another. Some application layer programs, if they communicate with other systems, the freeform packet headers are attached. So if you ask me, should you memorize? No need to memorize, just understand the concept. They can change their positions. If I want, I can change their positions, like I just remove this and change the position, it's allowed. You can increase or decrease the length. Okay, so this is called free from headers, which is not possible in the fixed headers. So with this I conclude this lecture, students. The summary of what we have reviewed in this lecture: network protocols, protocol specifications, network standards, TCP IP versus OSI layers and packet generation, crypto placements at different layers, protocol addressing and protocol headers. Thank you very much.